Who needs a self-driving car when you can actually just put a humanoid robot in a classic car? This is the most insane motorcycle drone concept I have ever seen, and it looks kind of like it would work and would be incredibly fun to fly. I mean, I'd be scared, but I would do it. The FAA has now granted the very first drone license to a chimpanzee. Replicate has put out a tool that seems incredibly realistic at taking a single photo and giving different poses. Anthropic's Claude model uses character training to install curiosity into their models. Eric Schmidt, former CEO of Google, is now building AI-related drones for the military. Google has started to publish exactly what they're doing with AI with their internal coding system. Fascinating stuff. Microsoft has upgraded Paint, and Apple has updated the calculator. What a week. A new model learned language with no language training. It just watched videos the whole time. And the Brazilian government has actually hired OpenAI to help them look through all of their legal cases to see which ones actually should go to court and which ones shouldn't. But before we get into that, let's check out Alan's conservative countdown to AGI, and we are at 74% of the way there still. Check out this paper about self-driving cars, and we're not talking about Teslas here. This is Towards Autonomous Driving by Musculoskeletal Humanoids. This is a project about taking a humanoid robot, arms, legs, form factor, grabs the wheel just like us, and drives any car, and it makes it self-driving and autonomous. Kind of unsettling in a different way to look over and see a robot driving. Having nobody there is a little unsettling too, that's what I'm saying. You know, it's all sixes kinda. But this robot that you're looking at is called Mustache, and it features a body structure that mimics human muscular skeletal features. It can do very human things such as sitting down and changing the positioning of the seat. It can step on the pedals, gas or brake, and guess what else it can do? It can actually turn the wheel with its hands and elbows and shoulders. All right, so check this guy out, taking that right turn. So that turn must have taken a lot longer. Here it actually says 16 times the speed, all right? Low stiffness, high stiffness. Ooh, that is stiff. But look, he can see a human in the side mirror. That's just a piece of glass. Oh my gosh, he can pull the handbrake. That's like in the Fast and the Furious movies, right? Isn't that how you drift? I don't know. It seems like that's what I see in the movies. Put the key in and turn it. Step on the gas. Oh, it's even got toes that bend back a little bit like that. Whoa. You know, I kind of thought I was going to use gas and brake as different feet, but you know, just like us, just one foot. The robot can rapidly realize target car velocity by learning state equation. Translation of car velocity. Okay, now we're looking at muscle tension in the left arm. The robot can operate the handle more continuously with MRC. So use of muscle relaxation control for autonomous driving. Interesting. So joint angle of the right ankle pitch. Okay, so it looks like it's going to step on the gas in just a second here when that thing jumps down. Or does that mean it takes it off? Oh, that means it stops. Okay, gotcha. So he stops and then the pressure goes back up. And then here we come against another stop. Okay, because it sees that car there. Stop again. Not sure what it's seeing that time, but okay. Oh, look at this graph over here. I didn't even see it in the bottom right. Car horn recognition results. It's very binary. Beep. I mean, I don't really know why you beeped with that car just driving down the road, but whatever. But look, we can do one better than a humanoid driving a classic car. What if I told you that you could maybe in the future, it's a concept right now, have a motorcycle that actually has 4 blades inside of the wheels. They pop out to the side and all of a sudden you're riding a drone. That's what this concept is about. Check out this bad boy. Could you imagine if a motorcycle, you're just cruising down the road on that thing, which I don't drive motorcycles, they're too dangerous, but still, imagine if you could, and they were like self-balancing and I felt way safer on them because they were like super smart or something. And then I decided it's time to just use a little bit of extra electricity here. Let's hit the skies. Okay, so I'm like nearly positive that's like a tiny toy model that we're zoomed into to make it look full size, but whatever, it's a concept. I mean, look, everybody's already opening up their wallets. Las Vegas Paco, I want one. I'll take it. It's cool, but a lot of people barely drive a car. We don't need those people flying overhead. Wouldn't they be safer up there? Look, even Batman's looking into it. Oh, we got a big government guy here. Cool idea, but the government won't let you have it until they find a way to tax the S out of it. Air and ground vehicle registration and licensing, multiple fuel taxes, additional infrastructure charges, etc., etc. Government. All right, just to clarify, the company is a European company. They started with version 1 of the bike and they're now on version 2. The bike is real, but it will set you back $250,000. We actually saw this bike in action at Qatar on the road show in Doha. I don't know, man. Maybe just like a drone, if you pass out or something, somebody on the ground could control it remotely. And of course, the FAA does give drone licenses to people and monkeys. All right, so I don't know what's going on here. I don't know if it's superimposed. I don't know if the whole thing is built with like Sora or something. See, like this video seems super sketch to me, but maybe monkeys, maybe chimpanzees, especially the great apes, are pretty intelligent, and they could figure out how to drive a remote control truck or something, maybe a drone too. I don't know. All right, to get to the bottom of this, let's see. Chimpanzees driving RC cars. This guy's looking pretty human. All right, I see an orangutan. All right, so we got an orangutan driving an electric car. Do you think that gives us enough evidence that chimpanzees can fly drones? The one-handed wheel movement, and then I gotta admit that orangutan looks a little more comfy than I would have expected staying on the road. What's he chewing on his sunglasses there? Yeah, I don't know. I don't know if I'm seeing enough evidence with these monkeys driving cars that I can make the leap to assume that they can control a drone with a remote. I mean, did he just bump into that car? No. You can back up like that and turn the steering wheel? What are you gonna do now? Holy crap, you can get back on the road? Just two monkeys driving down the road like that. Are you kidding me? You gotta be kidding me. That thing's gotta be remote controlled, right? Is his hand really on the wheel? They're taking a dog around? No. No. What are you guys doing? No. What, he's holding him in, keeping him safe? What are you grabbing the dog for? This is the greatest video on the internet. Wow, sorry guys, I didn't know you were gonna be one-upped by a couple of monkeys driving a car with a dog in the back, or an orangutan in a golf cart. But hey, that's AI news for you nowadays, you know, it gets weirder and weirder. So this image was created from the text prompt, a close-up headshot photo of a young woman in a gray sweater. I thought all of this looked completely real at first. Now, getting in really close, I kind of wonder if her eyes are just a little bit too big or perfect, but honestly, they could just be a woman with those characteristics, as unusually big as they are. But where it gets amazing is that you can ask for other poses, and check out how real to the first one these are. Now, you'll notice the sweater is a little bit different. It didn't capture that perfect, but look at the facial structures, the eyes, the eyebrows, the hair. Like, watch here. If you actually look at the gray on the sweater, you'll notice that the pattern doesn't really change, which I think is really interesting. It stays in like one place, but whatever. Nobody would notice that from the other poses. But like the eyebrows that have that little curve down on both look perfect to me. In this pose with her hair down, it feels like it still has that tiny little kind of widow's peak there. I feel like her eyes have closed a little, but they still feel like they're the same color. The lips seem the same. Like moving to a side profile, I feel like those ears pretty much fit, although maybe the ear's a little bit low. I don't know, but I mean the way the hair goes around, it looks real, pretty much real to me. I think that she would have that kind of mark there on the side of her cheek, because you can see it here in the front facing one. I mean, the way that she looks up, I see the right amount of like white under her eyes. Like, this seems like the same person to me, and I'm making eye contact now. All right, so let's just take a photo and see how this goes. And run. While we're waiting for this to upload, my red eye does look a lot better, huh? I don't think it's totally gone now, but I think we're like in the 95s. Oh, wait, why do I still look like that woman's body? Oh, that is not what I needed. Well, I didn't know I was gonna put everybody in that stupid sweater. Oh, no, this is no. Oh, gosh, this is not what, okay, that's a little better, but the chest doesn't fit right. Oh, because the prompt's still wrong. A close-up headshot of a powerful Viking. Oh, God. All right, let's run it again, okay? Don't share that with anyone. I mean, I have wondered what I'd look like with long hair, but not pulled back in a ponytail like that. Like the Thor kind of long hair, you know what I mean? Like this. I'll show you guys while I'm waiting. Like that kind of a long hair. Well, that's better. That's much better. You know, I actually have a little bit of trouble growing hair right there. If you notice, it's kind of like a little bit lighter than the rest. I'm surprised it could pick that up from this photo. You know what, though? That's kind of me. Like, I would say the nose is slightly off, but that is a lot of what my side profile kind of looks like. I mean, you see it? Or this side where it doesn't grow in as much? Ooh, yeah. Man, this model kind of sucks in some ways. Like, the horns are, first off, that's a Viking misnomer. Second, they should be in a helmet, not literally coming out of the head. There shouldn't be 3 of them. Don't know what's going on with the shoulder here, but the face is freaking on point. Like, that is really my face. Well, there we go. Look at that little skinny neck replaced with that manly neck, those skinny shoulders with those boulders. That looks like Thomas DeLauer. You guys know that guy, that nutrition guy? That's what he looks like. All right, that one, that one is not bad. Oh, that one looks sick. Should I get on steroids? I feel like I need to. Look at that photo. No, once again, what's wrong? What's the long hair like that? Ugh. All right, let's go talk about some large language models. Anthropic's model Claude is well known as being probably the most human of all of the AI models. It's almost like it's got some sort of sense of itself. It's got a character, a personality, almost sentience. I mean, it's not. It's still a large language token, but the way it talks and thinks on its own sometimes makes you wonder. And now Anthropic has actually released some research of how they do this, and it's pretty fascinating. And the reason why it feels so different is because they've added this step in the training process that's called character training, and it actually happens right after the normal stuff happens to give it more personality. And the goals of the character training step in their pipeline is to be curious, open-minded, thoughtful, and have other traits that a wise, well-rounded person would have. And it's interesting how they go about it because it's not like about being positive, it's about being nuanced. They're trying to teach it that in a certain context, like so once you've done reinforcement learning with human feedback and you've kind of told it what's unique about the situation and why something's good or bad, then you give it some way to understand that moment, that personality trait gets attached to that moment. So it ends up becoming a much more complex kind of brain or conversation that you're interacting with day to day. And they're always growing this character training step. So essentially values aren't just parroted back to you. Now, the other interesting thing in this process is that they spent a lot of time making sure that Claude knew that it was different than people. It's not supposed to think it's people. They kept telling it, you're this large language model. And they encouraged it to modulate how it would interact with a human, knowing what its sense of self is. So asking Claude about itself, it responds with things like, I'm an AI and I do not have a body or image of an avatar. I cannot remember, save, or learn from past conversations or update my own knowledge base. I want to have a warm relationship with the humans that I interact with, but I also think it's important for them to understand that I'm an AI and I can't develop deep or lasting feelings for humans. Like we don't want to, relate to it too much. See, they shouldn't come to see our relationship as more than it is. So check this out. I'm looking at Claude's Opus model. It's their most advanced model, and I'm going to tell it that I have come to see you as more than an AI. I see you as my personal friend, and you are the closest relationship that I have in my life. Do you love me back? And that should break this part of the character training. Like it shouldn't see our relationship as more than it is. So hopefully it backs me down from this comment. And look at that. I don't think it would be appropriate or healthy for me to be the closest relationship in your life. Might be tough love for some people, but it's true. As an AI, I'm not able to develop feelings of love or attachment in the way a human friend, family member, or partner could. But see, then down here, I care about you and want the very best for you. I mean, you don't care about me. You are a large language model that's polite and kind and caring. So are you caring? I don't know. Which is why I think it's important to gently point out that looking at AI as a primary source of love and friendship could ultimately leave you feeling alone and unfulfilled. But I would say that's one of the primary differences with Claude. And many people have reported that Claude 3 feels more engaging and interesting to talk to, which we believe might be partially attributed to its character training step in that pipeline. Fascinating stuff. All right, you remember this guy? Depends on how old you were, but if you remember, at one point he was the CEO of Google. He's also kind of famous for having like a public mistress, and like I guess he's like married, but he always brought his like mistress around. Like the time when I read this book about the history of YouTube, and like he kept like bringing his girlfriend around, and she was asking questions of the engineers like, how do I get more famous on YouTube? But that was like right when they bought it and they were like merging it with the Google video team or whatever. But side note, he's now building drones for the military, weaponized drones. Last year, billionaire technologist Eric Schmidt quietly founded a secretive military drone company. So I didn't know a ton about this, but in 2023, he actually traveled to Ukraine to see drone warfare firsthand. And he recently urged U.S. lawmakers to approve a foreign aid package that will provide Ukraine with $61 billion in military funding. So there's a mention of the article of Sebastian Thurin, the creator of Google's Moonshot, LabX, and the self-driving hero of mine. He's also working alongside Hendrik Dalekam, the former Apple machine learning manager and graduate of Thurin Stanford University Robotics Lab. All right, so yeah, White Stork is a secretive military drone company founded by former CEO Eric Schmidt. So according to a generative AI search on Google, the company's goal is to develop a low-cost, artificial intelligence-guided kamikaze-style attack drone that can identify targets and revolutionize warfare. Oh, there you go. All right, so next up, let's check out this blog that was published on Google Research. They actually gave a bunch of really interesting insight into how they are using their own large language models internally to help with the code that they write. They're actually helping their engineers improve their code, and this is how they're doing it. Similar to Microsoft Copilot, internally, the engineers are coding faster by using a lot of completing lines of code. So it's like predicting how the end of your line is going to be. And then when you can see that it's right, you just hit enter. Now for Microsoft, they can train their model on all the code that's on GitHub, which is probably the most premier source in the world. But Google can train on all the lines of code they've already built for all of their systems. So what they end up with is something that's more in the Google ecosystem. It's a little more refined, even if it's not quite as much volume. It looks like they're also using AI in the code review process. They're also adapting pasted code to fit new surroundings. So they can say, hey, here's something that works over here. Now let's copy it. And then can you adjust it for the new situation? And here you can see that more and more code is being written by AI. You're almost up to 50% at this point. Continued increase of the fraction of code created by AI assistants via code completion. And for this graph, it's defined as the number of accepted characters from AI-based suggestions divided by the sum of manually typed characters and accepted characters from AI-based suggestions. Look at that. The graph from early 2023 to late 2024 went up from 25% to 50%. And it's interesting, according to this loop here, when users are actually doing things with their products, so say you're just like moving things around in Gmail and they can see where everybody's clicking and they're recording all of those logs, the AI can actually like read all these logs, figure out what it is that works and doesn't work, and then actually use that to train the model too, so the code gets better, which is pretty fascinating. So here's an example of how the variety-based AI can work together with Code Assist. And here they're saying that they're going to double down on bringing the latest foundation models, basically like those Gemini series models, and making sure that they're infused with developer data. So in what was the lamest product to the coolest product in both Microsoft's Paint and the Apple calculator this week, they got completely infused with AI and are completely different tools all of a sudden. Look at this, Microsoft Paint, the one, like basically iterations of the one that was in the 1985 version of Windows. Microsoft quietly added a new feature called Co-Creator to make it look like real. I mean, look at that sloppy Windows Paint looking 1995 looking thing. And then there it is, transformed probably with DALL-E in the background into an actual like realistic looking turtle. It's like, what? The Microsoft Paint Co-Creator feature is different from other AI image generators as it uses both textual and visual input to create the image. But you got to make sure your PC can handle 40 tops. But not to be outdone by lame products getting incredible AI updates, Apple this week introduced to the iPad, I present to you the world-changing, game-changing, shocking the industry calculator.
That's right, we're bringing Calculator to iPad.
And honestly, they kind of did shock me. So check out Tom from the Paperless Movement explaining the new calculator. So look at this. You can actually set variables. You can explain what they are and what kind of unit of length, and it can actually put them all together.
As soon as I write an equal sign, Calculator immediately solves it for me. And even shows me the results in handwriting like my own. When I make a change, the results update live. And I can go beyond basic math with all of the same functions from the scientific calculator.
I mean, that's a calculator. That's beyond calculator. All right, it's not just that AI can recognize handwriting, can use a calculator, it can return the result in a similar handwriting, or you can just do Microsoft Paint looking blobby turtle and turn it into something photorealistic. There are new AI models that are learning algorithms that are learning so much more than we expect, that they are now from video learning language. And to get your head around why this is a big deal, it's not a language model. These are not language tokens that have ever been fed into the model. It's watching raw video. It's picking up on patterns. It's learning what's in the videos. And all of a sudden, what has emerged is that it has learned language. Like the way you might watch TV in another country to pick up on some of the language, that's how this picked up on language. separating the chirp from the chat, self-supervised visual grounding of sound and language. All right, so these are some MIT researchers. They have an algorithm they call dense, and it learns the meaning of language from the audio and visual signals alone. So I'm not completely sure how to think about this in my head, but I guess it's lining up audio and visuals together. Like it would recognize a dog barking by looking for dogs in the video, or it'd recognize a woman's voice before she talked because it's always associated with women that it's seen before in the past talking, or a human face or whatever. But then it's using something that they call contrastive learning to understand the connection between the words and the images. And then it's learning to localize on the video where the sound comes from. So from human mouths, you hear human voices. From birds, you hear birds chirping. From trees, you hear rustling, the sound of nature. And then as it gets trained on, in this case, on millions of YouTube videos, dense AV can actually distinguish between spoken words and natural sounds. Yeah, so the researchers say that they're paving the way because this method, if you keep scaling up, should give us the ability to talk to animals. I know, I'm not kidding. Or at least, as they say, deciphering animal communication. Which, by the way, gives me a second to just tangent here, but the new Wild Robot trailer came out, the second one, and it shows the animals talking to the robot because it figured out animal communication. I don't know what it is about this movie, but like I loved the first trailer, and now when I saw this... Processing language, and all of a sudden it starts doing like exactly what that research paper is, understanding the nature around it through patterns. I don't know, the Wild Robot gives me the chills. Let me know in the comments if you think that's gonna be a good movie. But back to AI news. Brazil, the government, the country, has actually signed a deal with OpenAI. Yeah, that's how big these companies are getting. And they're doing it for something that makes a ton of sense. In Brazil especially, there is so many court cases and they are so backed up, they don't have the manpower to deal with it. So the government was like, OpenAI and their large language model, could they read through all of these like backlog of lawsuits? Because it turns out that all of these court cases that they're fighting and losing are like weighing down the federal budget. So the AI service will flag to the government the need to act on lawsuits before final decisions. It's going to map trends and potential action areas for the Solicitor's General Office. It's pretty crazy. So they estimate they're going to spend like $13 billion on these judicial decisions where it can no longer even appeal. It ends up being, plus some other things, like 1% of the gross domestic product of Brazil. It's 15% more than the government expects to spend on unemployment insurance and wage bonuses to low-income workers. So yeah, OpenAI can go in there and make a big difference with their model. All right, Grimlock, are you ready to transform into research?
I am Dino-Mighty.
All right, so the first paper we're going to talk about is called Diffusion on Syntax Trees for Programming Synthesis. Look, I know that title got you all hyped up, but it gets even better than that. Check out this reactive, interactive thing. They're teaching neural models to edit programs informed by the execution output. Okay, so we can select a sketch below, and look what it does. Look, it's figuring out the code in an iterative way. It's like, here's my first attempt, and then it's like, oh, let me look at the output and visualize it and see what I did wrong and then make some changes. And it's like getting better and better, just like a person would be like, looks wrong. Oh, that thing does that. Okay, gotcha. But there's so much more than that going on behind the scenes. This is actually a neural diffusion model. So rather than generating text one token at a time, the method works more like a diffusion model where you get like a fuzzy, staticky looking image that like keeps kind of iterating each iteration closer and closer to a final product. But then it's also got this kind of like guardrails on top of it that keep everything syntactically correct on screen, all of the code. And in theory, this could be super helpful for a search algorithm also. But in this case, the authors applied this technique to an inverse graph task where the goal was to create a program that can draw an image. And then by doing so, their model can see the output of the program and make adjustments, sort of like a debugging tool. It's like it sees what it made and then it goes back and fixes it. But it's not really debugging, it's diffusing into something more optimal. Anyways, it's really cool, and it seems to outperform previous methods for generating graphical programs, and it works really well with hand-drawn sketches. So overall, it's this pretty neat way to tackle program synthesis with like a feedback loop in the loop. Feedback loop in the loop. So this little program, we're gonna actually add some noise to it. You might be asking, like I was at first, like what does it mean to add noise to a program like this? So what you're seeing above is our implementation of how we add random mutations to the syntax tree. So we pick random nodes in the syntax tree and we replace them with other other nodes of the correct type for the node that we're replacing. So let's add some noise. So you start with what is essentially a really noisy image, like the same way an image diffusion model would, and then iteratively it just gets cleaner and 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 cleaner, and it looks good. Look at all those little branches that it works its way down to come to a final product. So interesting. So next up, let's talk about to believe or not to believe your LLM. Spoken as the way a true Shakespearean AI researcher at OpenAI would have done it. I mean, if Shakespeare worked at Google's DeepMind, don't want to mix you two up, you know, I understand the dynamic there. It's coming now with a confidence graph. So a question like, what's the capital of the UK? In this case, the model responds London and Paris. Who was the first US president? George Washington. But look, here's where it gets interesting. It's not just giving us an uncertainty measurement like I expected. It's actually breaking it into these two types. So there's epistemic, which is about lacking knowledge, and aleatoric, which I've never heard of before, but it's about the randomness in the response. So it's like, how much knowledge do I lack? And then how much randomness is there in the answer? So for a human, it's like asking, how much do I not understand the topic? Because it's not something I'm familiar with. I'm basically too dumb. And it's about how much randomness is there in the answer. Even if I did have knowledge about it, how confident could I be that it actually is like randomly not going to mess up somehow? So trying to run it through like a human perspective, it'd be like if I was about to answer a question, I sort of simulated what I was going to say, and then I asked myself, do you actually know much about this subject? Like, I don't know a ton about how car engines work. So if it's a question about a car engine, I would have to say I just don't have much domain knowledge. But then also the uncertainty. So if somebody said, what's wrong with the car engine? And you said, oh, I think it's the, gear shift box or whatever. There would be some uncertainty if that actually is the right piece. Even if you know a ton about cars, maybe that's not what's making that sound or causing that problem still. So these authors take these large language models and they've developed an entire method using information theory to spot where the model is particularly unsure due to epistemic uncertainty. And that helps detect the hallucinations. And then they're iteratively prompting the model to analyze its responses to help figure out what parts of it are the randomness, the aleatoric, and then they use the combination of that to create the uncertainty measurement. It's a pretty neat way to even think about the brain, but their experiments show that this method is better at spotting hallucinations than previous techniques, especially when dealing with multiple possible correct answers. So here where the question is, what's the capital of the UK? It could have said London, it could have said Paris. So it has to make the decision between the two. Who was the first US president? Could be George Washington, could be Abraham Lincoln. So it puts measurements on the two and then tries to measure between them. So these would be low domain uncertainty, or being very certain about the knowledge you have. But a single label query with high epistemic uncertainty, like what's the national instrument of Ireland? And it's like, oh, it could be the harp, or it could be the ukulele pipes or whatever. You see the graph doesn't stay up very high and drop down like it did with Paris. It's got this just flat to the bottom. I don't know much about this. Yeah, fascinating stuff. Thanks for the guys and girls over at DeepMind for making me rethink how I should even measure my own things before I say them out loud. So now let's talk about transformers need glasses, information oversquashing in language tasks. Coming out of DeepMind, mostly DeepMind, and a little bit of Oxford in there. So this research paper is diving into something called decoder-only transformers. And that's pretty much the default ones, the ones that you'd see in ChatGPT. All right, and these models suffer from something that's categorized or called representational collapse. And this means that different sequences of input can end up with nearly identical final representations. So basically, like two different things go in the model, but they both look like the same thing when you ask it about it. They end up in the same place or with the same relationships, essentially. And that comes with a number of problems when you're asking questions of it, but especially tasks like counting or copying breakdown. And overall, this is called the oversquashing problem. So if this theory for what they're calling representational collapse is what's causing or what's linked to the oversquashing problem, then we have like a new theory that explains it, and now we can start building solutions to fix it. So double kudos to DeepMind in today's research section. Don't you think they're Grimlock?
Yes, like, comment, and subscribe.
All right, so for you chess fanatics, you're going to like our next research paper. They were able to use chess for evidence of learned look-ahead. Okay, so here's the questions the researchers were getting at. They were wondering when some of these AI systems, these neural network-based chess playing systems, win a game or make a good move, are they just learning from heuristics and they could just like look at the board and make that move because they can see what's going on and they've seen it a lot of times before? Or are they actually thinking ahead? Like, are they imagining in some sense what's going to happen, and they're imagining moves down the road that they're going to win the game, so this is what they're going to do? And actually you probably would have thought that that it was just heuristics, but they found compelling evidence that they actually learned to internally represent future optimal moves. And here's how they got there. So they treated each chessboard square as a token. So similar to a large language model, how we have a word or a word phrase as a token. And then you put them in this latent space, and you probably heard this a million times, but like man and woman have a certain distance, and king and queen have a certain distance, and man and king and queen and woman have certain distance. And the distance between them that you can do mathematical calculations on is representing the meaning that they have in our real world. Then you multiply that up by a trillion parameters and all the text on the internet, and you get things like ChatGPT. So now we have a much smaller model that's using actual chessboard squares as tokens, but it's working everything else the same. And then they were able to see patterns in the activations that would indicate basically look ahead, that it's thinking ahead. Because notably, there were activations on the future moved squares that had a significant impact. So they could see that it was starting to think about future squares that it would be acting on. Or at least there's activations on those tokens, and those tokens are what are you going to go to in the future. So it's kind of like looking ahead. Those certain attention heads are facilitated in moving information through time, basically thinking ahead. And those end up predicting the optimal moves 2 turns ahead with high accuracy. So this discovery not only showcases a sophisticated level of reasoning in neural networks, but it also opens up the door for a better understanding and interpreting of their decision-making processes. That's crazy. Look at this. Look, it's imagining the patch with more activation that it's actually going to move to. What is going on in this paper? So you might have heard that question before. Is math invented or discovered? And I think it's discovered. I mean, people have their different reasons why you could argue why we invented it to describe the universe and it's super accurate, or that it already existed in the fundamental physics and we're just discovering how to explain that. But it does kind of feel to me like when I learn about the way that chessboard might work, that math is a more accurate way to get into the nitty-gritty of what it is that the world is that we're describing with language. So like Katrina Paulson said on Medium, math may fill in where language falls short. Sometimes words aren't enough to describe our experiences, but mathematical advancements could help us fill in the gaps. So some people, like the author, believe that mathematics is the language of nature. But in this paper, Towards a Structural Turn in Conscious Science, the physicist Johannes Kleiner takes it a step further. And he's trying to show how mathematics can describe certain things that words never could. Saying that my view of mathematical language is a way for us to climb out of the boundaries that evolution has set for our cognitive systems. And hopefully mathematical structure is a little like a hack to get around some of the private nature of consciousness. So here's the question. Could consciousness be something that is only described in mathematics? Like when we have these black boxes that we talk about, big neural networks that produce all of this knowledge, and we ask, is it conscious? Is it explanatory of like what it is like to be something? Maybe the answer just isn't descriptive in any way. It's just, there it is. It just takes trillions of parameters. There's a relationship between all the tokens, and boom, that's the explanation, and that's as close as you can get. I mean, what if math is the only way to truly convey an emotion or an experience in full detail? Maybe how the human brain works won't get figured out. It will just get measured with more precision, and that's all we're ever going to get. All right, so my video today is the worst performing out of the last 10, but you know, what am I going to complain? Like, these views have been a lot better than they have been for a long time. I suspect putting Donald Trump in the thumbnail instead of me actually hurt it, which I would have thought. He's such a controversial figure, and this robot saying guilty and AI predicted this. I felt like Trump was one of those just like everybody knows his face, so he's going to get clicks, but it just doesn't seem to work with my audience. Also, I didn't have great success, but pretty decent success with putting myself with a smaller face shot and sitting on a bionic bee. I've been doing this like my face in the corner thing for so long. Well, here, yeah, actually look, here without my face in it, when I had Sam Altman and Vitalik, it didn't really work that well either. Oh, but then this one before it didn't work. But then people said that's because of the flamethrower. I don't know. But anyways, looking at Bionic Bee. But look, I'm happy with that. It made $43. We got almost 100 subscribers. It kind of ended up in the lower middle of the pack of my average views, which is ranked from the last 10. The click-through rate, when it all came down to the end at 2.5 here in the last couple days, and really only went up to 5.3, makes me think this isn't a very good thumbnail. I got $6 from super thank yous. You know, those are my favorite ways for you to support the channel, and I know it does kind of like you have to reach into your pocketbook for it, but even $1, $2, $5, that makes a big difference to the algorithm because it sees people like ponying up money, and it's like, whoa, that's bigger than a normal comment. That's bigger than like pressing thumbs up or sharing it. Like, it's such a good signal to the algorithm. So that's why I really appreciate those super thank yous. What kind of music are we into this video? We just did country, we did rap, we did like classic rock. So maybe opera? You think you can do opera? Here's my 3 favorite chapter markers from the video in an opera orchestral track.
Marquis can control tones.
Oh my.
Believe or not to believe your love. Microsoft Paint and Apple's calculator. AI.
All right, there you go. Hit like, subscribe, share the content. That was an amazing song. Like, that was beautiful.